Hi, this is Don Gettner with Ridge Engineering. In this tutorial, I'm going to show you the changes that have been made to PC Warrants to support the new warrant number 9, that has been added to the 2009 MUTCD. I'm going to assume that you're familiar with PC Warrants in this tutorial, so that I won't go through all the details of how the software works. If you're new to PC Warrants, then you may want to take a look at one of the other more basic tutorials that are on the support website at www.pc-warrants.com. So I'm going to assume that you're a current user of PC Warrants and you just want to find out about this new warrant that you've heard about. So we're going to start PC Warrants, and I'm going to open up a warrant study that I've created to make this demonstration a little bit easier. And the first thing that we really need to talk about is the site data. Now, again, I'm assuming you're a little bit familiar with PC Warrants. So this is the site data screen, and you'll notice that there are a few little changes. One is there's a section down in the lower right for the new rail crossing warrant, and it has 5 different sections. I'll explain those sections in more detail when we get to the Warrant 9 details screen. But these are the 5 things that you can change about this warrant that will affect whether or not the warrant is met. Now, the warrant only supports railroad crossings that cross the minor approach. So on your intersection drawing, the software figures out which is the minor approach, either by the volumes or by you explicitly saying which is the major approach. So here we have the major approach is in the north-south direction, and the software shows 2 little buttons that you can select to show where the railroad crossing is on that approach. So in this case, we're going to say that the railroad crossing is on the westbound approach, somewhere out in here. And we'll put in some more information like the distance from the intersection to that railroad crossing, because that's an important parameter. Most of the other parts of this screen are the same as you're used to. Now, we also made some changes to the pedestrian warrant, and so there's a slight change to the parameters for the pedestrian warrant. That's explained more thoroughly in a tutorial that is focused entirely on the pedestrian warrant. Again, you can see that at the support site on the tutorials page. So for the moment, we're going to just say that this railroad crossing is on the westbound approach, and I'll explain these other parameters that you can fill in. In a typical application, you would fill them in at this point, but I want to be able to explain what they are and show how they affect how the warrant works. So I'm going to do that on the details screen. So we're going to click OK to go back to the main screen, and now we're going to click on the Warrant 9 intersection near grade crossing details screen. So this is brand new, so you haven't seen any of this before. Of course, it looks like the other details screen in that it has all the information that we know about this intersection, and the information that's required by the warrant is up in this section. Since this warrant does use the vehicle volumes, it shows the vehicle volumes in this section down here, and it calculates the major road hourly totals, and it calculates the minor road totals for the direction we've selected for the railroad crossing. So since we selected that the railroad crossing is on the westbound approach, we're seeing the westbound minor approach volumes on the screen. Now, in order to meet the warrant, there are not fixed values for the major versus minor. They put in some of the graphs that they like to use, And if you're familiar with the graphs in the other parts of the signal warrants, you'll see that these are a little bit different in that although they do graph the minor approach total versus the major approach total, instead of having one broad curve that they just drew roughly by hand after deciding how they wanted it to look, they made these graphs out of straight line segments. So you can see if you look at this graph that it's made out of straight line segments. So the software has to calculate these line segments and then plot them on the screen, and then it plots the major approach totals versus the adjusted minor approach for the approach that is on the side of the railroad crossing, and any points that are above the curve meet the warrant for that hour, and any points that are below the curve do not meet. In this case, we have lots of points that meet the curve, but there are ways of adjusting the curves based on the settings up here that may or may not change that. The first criteria is the distance from the rail crossing to the intersection, and that's called the clear storage distance in the warrant. And if that is greater than 140 feet, regardless of any other parameters that are at that intersection, the warrant is not met. So if you set the clear storage distance to greater than 140 feet, then everything else is a moot point. And you can see that when I do that, the curve goes away because there's no curve for that situation, and the summary is that the warrant is not met. So that's not very interesting. So let's see what the effect is if there's different distances. So if it's 130 feet, you'll see there's a curve that looks like that. If it goes to 110, you can see it goes down a little bit, and there's a whole series of curves, with the basic idea being that if the distance to the rail crossing gets less, it should be easier for the warrant to be met, and that makes sense. The idea of this warrant is to provide a way to get so that cars do not get stuck backing up on the minor approach, waiting for a gap in the major approach, such that they actually back up and get near the railroad crossing, which is an obvious safety issue. So the closer you get to the intersection, the lower the curves become. And so let's just set it to 90 in the middle somewhere. Now there's also effects on whether or not there's one lane or two lanes on the minor approach. Again, the idea is that if you have two lanes, then you have more capacity to store vehicles before they start backing up towards the railroad crossing. So if you have two or more lanes, it's a little bit harder to meet the warrant than if you have one lane. That makes sense. They also have three parameters that can be used to adjust the minor volumes. These are factors that are used to calculate a new adjusted minor approach volume, and one of them is the percent buses on the approach. Now this is actually the percent buses that have at least 20 people on them, and presumably you will have to do a study of some sort or another to figure out if this approach has a lot of buses. I guess the idea is if you have a lot of buses, that's a greater safety hazard, because if a bus gets stuck on a railroad crossing, much worse than if a car gets stuck on a railroad crossing. So it's your responsibility to somehow calculate these numbers, and you can see that if the percent of buses is between 2 and 4%, then the adjustment factor is 1.09, and what the software does is it calculates the minor volumes and then multiplies the minor volumes by this number. So again, if I go back to the 1.0, you can see these numbers, which is the minor volume, that's the up and down here, changes just a little bit because it's being multiplied by 1.09. So the bigger the number here, the higher the value, and the easier it will be for these numbers to be above this line. So the more buses that you have, the more likely the warrant is to be met. Again, that makes sense. There's another variable called the percent of tractor trailer trucks. Again, you don't want tractor trailer trucks to be stuck on a railroad crossing. So the more trucks you have, the more likely you are that there's going to be a problem. And so if you have no tractor trailers, it brings the numbers down quite a bit. It's a 0.5 factor, so that's a very significant number. If it's 12.6 or so, it's a 1.15 factor. And again, you can just play with this. And if you have tons of tractor trailers on here, it's going to be very easy because you're multiplying the minor volume by 2.09. So again, we'll go back to the 1.0. And then the amount of rail traffic is important because obviously if this is an abandoned railroad crossing, you don't have to worry about cars being stuck on it. And the more rail traffic that you have, the higher the danger level, and so the higher the calibration factor becomes, or the adjustment factor becomes. So if you have just one per day, then you have one set of numbers. And I guess if you have 0, you wouldn't be evaluating this warrant. So you have to have an active rail crossing, and then you put in the numbers. And the warrants, the curves were designed assuming 3 to 5 rail crossings per day. So if you have less than that, then the numbers actually decrease a little bit. More than that, and the adjustment factor is greater than 1. So the software looks at all the values of these settings, calculates a total adjustment factor by multiplying these three numbers together, and then multiplies the actual minor volume that was in the volume data screen by those numbers, and then plots it on this curve, on the graph, after it has plotted the curve that is set by these numbers. Now, one last parameter is the peak hour used by the rail. And the idea here is if you know when the rail traffic occurs, if it coincides with a vehicle peak hour or near peak hour, that's likely to be a more serious situation. So if you know when the trains go by, and you can pick 1 hour that is the peak hour for that situation. If you select that, then the software simply uses that 1 hour and it plots that 1 hour for the minor volume. It also uses the adjustment factors. If you don't know that information, which is probably going to be fairly common, it's going to be difficult to go out there probably for 24 hours to find out when the trains come by. They may or may not come by on a regular schedule every day. So this could be difficult to figure out. So if you leave it set to unknown, the software simply plots the highest volumes, and then you can use your own judgment to decide whether or not the warrant should be considered met or not. So there's quite a few little parameters in here, and they do a lot of little adjustments to the curves and to the plotting of the points. This is one warrant where the software really is a very big help. because you just put in the numbers, it calculates everything for you, and then it gives you the answer. So you can go back and forth between the graph and the volumes, and the volumes will actually change as I see. Here's a 256 for this number. If I select this where I get a factor of 2.09, you can see it's gone all the way to 535. So I'm actually multiplying the numbers in these columns by the adjustment factors. Now, once you've put in all this information, the software calculates the warrant. It shows it down here whether it's met or not. And when you print a report, at the moment, it just has a very simple one line at the bottom of the older report that says whether or not the warrant is met. In future versions of PC Warrants, we're going to have more extensive reporting options. At the moment, there's just the one line at the bottom that says whether or not it was met or not. I'm going to close this. So remember, the site data, now here's all the information. This is where you typically would enter this information when you first are into the site data. How you're going to get this information is kind of up to you. The percent of buses, the percent of tractor trailer trucks, that assumes somebody's been out there doing some studies. Good luck. That's about all I can say. But once you have that information, it's very easy to get it into the software and to get an answer. Okay, that's it. That's it for Warrant 9, and I hope this helped give you an idea of how that new warrant is going to work.